What's up guys? Welcome back to my YouTube channel. So now, for this video, I will teach you how to make a load schedule in electrical. Okay? Are you ready? Let's go! Okay guys, now I'm going to teach you how to make a load schedule. Okay, now, first you have to calculate first the appliances. Like say for example, you have to take the power, no? The power rating of the appliances. Let's say for example, we're going to put the lighting. Lighting, we have 5. Okay, 5 lighting each. Each light consists of 100 watts. Okay, so that would be 500 watts. Okay, let's say for example we have the TV. This is only assumption of power. The power rating of the TV. So let's say for example 500 watts. Then the computer, let's say for example 500 watts. This is only an assumption guys, no? So it's just teaching. Later on, you need to take down the power rating based on the nameplate of the appliance. Okay? So sana tayo? Computer, 500 watts also. Now, meron tayong washing machine. Let's say, for example, 500 watts. So, ilan na yun? That would be 2,000 watts already, no? Then, let's say we have the heater, or the heater is, let's say, for example, 500 watts. This is only assumption, guys, no? I just teaching you how to calculate. Now, so overall, we have 2,500 watts. Now, in residential, we only have single phase. Okay? We are required to use only single phase. Okay? 3 phase for industrial. So, single phase. So, our voltage system is 220 volts. No? Sa mga residente, yan ang ginagamit. So, 2,500 divided by 220. Okay? So, you need to calculate. Okay? So, if you're going to divide 2,500 divided by 220, bakit ganon? Dinivide ko ng 220. Because power is equivalent to the current times or multiplied by the voltage. So, we're going to compute for the current. Okay? So, therefore, 2,500 no, divided by 220, which is the voltage. So, we could now compute for the current. Okay? So, based on the calculator, we have 11.36 amperes. Okay. So, guys, nakuha na natin yung total. Therefore, the overall ampacity is 11.36. Okay? Ampacity means for the rating of the current. Okay? Which is the full load current. Now, we have here 11.36 times, no? 1.25. So, you need to ano yung 1.25? Meaning, 1 is for the 100% demand factor. Okay? So, that's meaning we're using 100% demand factor. Then, additional 25% for the future expansion. So, we have calculated 11.36, which is the current, no? Based on the computation, times 1.25. So, we have 14.20. Okay? 14.20 amperes. So therefore, what breaker we're going to use? We have the ampacity of 14.20. So therefore, we need to use 20 amperes. Pasok pa. No? But for me, I suggest I'm gonna use the 30 amperes because this is the overall power circuit breaker protection. What is the circuit breaker protection? This is the protection for the over current interruption. Okay? So we need the circuit breaker to protect the line or the power layout, the power outlet that we're going to use for the appliances. Okay? So, kuha nyo na yan guys, no? So, therefore, the overall circuit breaker is 20 or 30 amperes. Now, for the calculation, kasi we're going to use the circuit breaker or the panel board. No? So, the main breaker, let's say for example, is 20. Okay. Now, for the load, okay, no? Each one. Sinabi natin, meron tayong, let's say for example, sinabi natin, ang ilaw is total 500 watts. Okay. So, 500, no? Ito na yung magiging protection natin sa bawat appliances. The main is 20 or 30. You could be used that as the main circuit power protection. Circuit breaker protection. So, 500 watts. This is for the lighting. No? 500 divided by 220. We have 2.27. So, we need to use, ano pwedeng gamitin? Amperes times, then you need the protection, 1.25 each. 2.84. So, ibig sabihin, you could save to use what? 10 amperes na circuit breaker. Pasok pa kasi 2.84 lang yung lighting. Now, we need to add also guys, no, nakalimutan ko, the layout for the power. Yung lighting, no? So, we need to lay out the power. Let's say, for example, the calculation. Power layout is overall 500. Based on the ano, no? Kasi normally, pag nag-calculate ka sa PEC, no? Based on the square meter. No? The location. So, definitely. Okay. Like say, for example, the assumption for the power layout rating, no? Ang overall natin is, lagay na natin 1,000 watts. Okay? Each guys. Or, say for example, 500 watts each times 5. That would be 2,500. So, you're going to add to the total, no, for the appliances. 2,500 plus 2,500 5,000 watts divided by 220. So we have 22.72 guys, no? So times 1.25 for the future expansion, 28. So therefore 30 amperes safe na yon guys, no? Ngayon, maglalaan na tayo sa lighting. Sabi ko 500 divided by 220. 2.27 times 1.25. 2.84. So, ano gagamitin natin guys na protection? 10 amperes is enough. Then yung kable mo, ano gagamitin natin? 12-14 lang yan, guys. So, pasok na yon 12, 3.5 or, yeah, 3.5 mm squared. 3.5 mm squared, guys. Yan ang gagamitin mo. 3.5 mm squared for the power cable. That's for the lighting. Protection mo, 10 amperes. Now, for the television, 500 watts. Same thing. Pare-parehas na siya, guys, no? So, you have to use also 10 amperes. No? For the computers, 500 watts yung assumption natin. So, therefore, 500 watts, same thing. Divided by 220. Also, 2.27 times 1.25. 2.84. So, anong cable na gagamitin mo? 3 point based on the PEC. Later on, I will teach you how to use the PEC, no? Doon ka nagbabase. Yung Philippine Electrical Codes, yun yung ginagamit namin for the power cable sizing and for the circuit breaker protection. Now, so, therefore, ano yung mga conduit na gagamitin mo dito? Maliliit lang yung kable, 3.5 lang. Only 1 inch is enough. No? Ito yung rule of thumb yung ginagamit ko, guys. No? Hindi pa ako nagpi-PEC dito. This is only an estimation. Rule of thumb. Based on the calculation. Okay? Later on, I will discuss one by one. Engineering electrical load schedule. No? But this is the basis. Okay? So, nakuha na natin protection ng computer, TV, then 500 watts. So, same thing, no? 10 amperes. So, overall, we have 5. 30 amperes, guys. 30 amperes na main protection. Tapos, sa ibaba, no, ng main, no? So, we have 10, 10, 10, 10, 10. Na load for the lighting, power layout, or else. No. For the power layout, yung mga saksakan, guys, kasi ang calculated natin, sorry is 2,500, di ba? Divided by 220, 11.36 amperes times 1.25 equals 14.20. So therefore, for the power layout daw, yung mga saksakan na gagamitin natin sa appliances, meron siyang protection na 20 amperes. Now for the sizing of the cable, 4.20, no? So ititignan natin sa PEC yun. Pero ito, normally 14.20, pag nakita mo sa PEC yan, 14 amperes, pasok pa yan sa 3.5. Or, you have to use 5.5 to be safe. Okay? Kasi medyo mataas na yung kuryente niya, 14.25. Okay? So, gagamitin na natin, we have to use 5.5 mm squared. Okay? Now, tapos na tayo sa power layout, sa computation ng appliances, sa wiring ngayon. Now, sa pag-wiring kasi layout, you need to mark, so set the location for the proper power layout design, no? Normally, kapag lalagay ng layout, kailangan mataas. So, it depend on the location na gusto ng customer o ikaw kung ano design mo. But basically, ang saksakan kasi, nakadesign yan, may siguro mga 3. No? Ang switch naman, meaning 3, mga 0.5. No? Depende. Meron naman 1 meter na power layout. So, it depends on the location, no? Pero for the switch of the lighting, normally, 1.2 yan. Pwede, no? Which is above. Mataas siya doon sa saksakan ng kuryente. So, pwede rin yung layout mo ng power layout. 1.2. Yan, standard yun. No? Pero makikita natin sa PEC yan. Re-reviewin natin guys, no? Sa PEC. So, yun ang pinaka-bible namin ng mga electrical engineers, no? Tatandaan nyo yan. Ituturo ko sa iyo later on yan, guys. But for now, load scheduling tayo. Now, let's say for example, may groundings dapat yun. Now, for the housing of groundings, binabaunan mo para hindi raw makuryente, no? So, how many groundings we're going to use? Magkakabit tayo ng grounding rod doon. Siguro, mga, ang size doon, mga 1 inch. Babaon mo doon sa ground para meron tayong groundings. Okay. Ngayon, sa pagkakabit ng kable, guys, no? Power layout. Tinitesting yan. Normally, mini-meger namin yan. Meger means insulation resistance test. And for the groundings, grounding resistance test. So, tinitest namin yung resistance. Supposedly, sa groundings, pag nag-testing ka niyan, meron kami equipment. Dapat, niya 0. Now, doon sa mga opacity naman, mini-meger namin, meron kami ginagamit na insulation resistance test. So, mga 500 lang. No? Niloloadan namin ng 500 volts para doon sa kable. Bakit daw? Para ma-check yung kable mo, is okay. Whether or hindi siya sira, hindi siya grounded. Okay? Otherwise, ayan, nag-aano na yung capacity ng cellphone ko, guys. But for now, yan muna tinuro ko, guys. Later on, I will discuss one by one. Okay? So, until next time, guys, sa mga kapit sa paigo dyan, sa my fellow engineers, to my staff, shout out sa Twin Rivers Corporation, sa mga tao ko dyan sa Cavite. Okay? Peace to everyone. Before I forget, guys, yung mga engineers dyan, no? Please subscribe, like, share, and comment, no? Later on, guys, yung mga fresh graduate dyan, electrical engineers, tuturuan ko kayo, marami. Mga equipment sa genset, sa PLC, sa MCC, which is Motor Control Center, SCADA, Supervisor and Data Acquisition. Ituturo ko sa inyo yan, guys, ha? Lightning protection. So, sa mga voltage system, motor control wiring, ituturo ko later on. For now, load scheduling muna tayo ng mga small appliances. Okay? So, hanggang dito na lang, guys. Please subscribe, like, and share, and comment to my channel, guys, ha? This is Cesar Castillo, CAC TV. Peace.